Welcome to Raise the Line with Osmosis.org, seeking solutions with leading experts on how to increase healthcare capacity so people can get the care they need during the COVID-19 crisis and beyond.
Hi, I'm Shiv Gaglani. We've spoken to many guests on Raise the Line about how artificial intelligence is enabling specific improvements in healthcare administration and the delivery of care. But today, we're going to widen our lens to look at the broader implications of AI for transforming entire industries, including healthcare. We could not have a better guide than Dr. Karim Lakhani, a professor of business administration at the Harvard Business School. For one thing, he literally wrote the book on this topic, Competing in the Age of AI, with his HBS colleague, Marco Ianciti. He's also one of the foremost academic experts on open source software and crowdsourcing, and pursues all of these interests in his roles as Principal Investigator of the Crowd Innovation Lab and NASA Tournament Lab at the Harvard Institute for Quantitative Social Science, and co-director of the Harvard Business Analytics Program, among many others. And it was my pleasure to see Dr. Lakhani present last month at in my 5-year HBS reunion, where I went up to him and talked to him about AI and healthcare right after his talk. So, Dr. Lakhani, thanks for taking the time to be with us today.
Shiv, glad to be here. And, you can call me Kareem. You don't need to call me Dr. Lakhani. I look behind there are some uncles and aunts that are also Dr. Lakhanis. And so,
My med school hat has me calling everyone doctor and professor, but my business school hat, everyone's first name. So
yeah. Let's stick with our first names.
So obviously, Karim, I know a lot about you and your background, but for our audience, which typically hears from people who are healthcare specific and then broader later, can you tell us about what got you interested in technology and innovation in the first place?
Yeah, so I, did my undergrad in Canada at McMaster University in electrical engineering and management, and then my first job actually was at General Electric at that time in their medical systems division. I was in the technology leadership program, which drew me rotations across GE's healthcare business. So I remember my first encounter was to go hang out with radiologists at the Toronto General Hospital, bring them donuts to the staff, and understand how they were using their various X-ray equipment, CT scanners, MRIs, portable X-ray machines, and so on and so forth. And for 4 years, I spent time in new product development, sales, and marketing roles at GE. So that really got me into the front lines of sort of one aspect of healthcare delivery and technology, because radiology is so technology focused. And it was in that experience where I first encountered open source software. And I was like, whoa, this makes no sense. Amazing software for free? Like what? I sort of had that in the back of my mind. I ended up at MIT to do my master's. And that's where sort of trying to integrate and understand sort of how new technologies were being used and were changing our models of how they were being developed and how they were being adopted, led me down to a career of first doing my master's, then spending a few years at Boston Consulting Group, and then coming back to do my PhD at Sloan at MIT on understanding sort of these rise of open innovation systems. So healthcare was sort of the start of my career. Healthcare and technology was the start of my career. And since that time, sort of this model of distributed development and innovation has sort of taken over the rest of the world. So you see these platform companies show up and do amazing things in a range of industries. And that's where, as I started working at HBS at Harvard Business School and continuing my research, but also writing cases, saw the convergence even more so of technology inside of businesses. And so, the Andreessen Horowitz, Mark Andreessen thesis on software eating the world really sort of became sort of an organizing principle for a lot of the research that I was doing.
Yeah, no, and it's incredible how much has changed since he first wrote that piece. I think a decade ago. And I don't know if you saw Ben Horowitz just posted that Andreessen Horowitz is moving to the cloud fully. They have a couple of
yes.
Yeah. So, obviously AI, it's a very charged term, right? A lot of people think they understand it, but they aren't often talking about the same exact thing. What is the current definition of artificial intelligence? If you're explaining it to a future doctor, what should they know right now?
Yeah, look, I mean, I think, I'm probably get into some kind of a hate war and some kind of a fire brigade with people about what the definition of AI is. I mean, I think what I like is actually what the computer scientists have sort of said. There's weak AI and there's strong AI. Weak AI is basically algorithms that do what humans once did and maybe do them better. So narrow tasks. So, for example, image recognition, anything from what you do with your iPhone when it unlocks itself, or your Android phone unlocks itself and it sort of looks at your face, to other fancy things that humans do. And then there is the strong AI, which is sort of the work of science fiction, which is, I read a lot of science fiction, so I read a lot of strong AI, but it's science fiction. It's like autonomous machines doing their own thing. And weak AI really, for me, is statistics at scale with lots of data and automation built in, right? So you take computer science, you take statistics, you mash them up, and then you get it going. And then we can start to apply it to a range of things, from book recommendations and movie recommendations to directions to lung cancer detection, and so on. And so we're seeing lots of applications of weak AI across the economy, and that's where all the action is today.
I like how you've broken it down on those two, because we've had, in the realm of science fiction, there've been a lot of these kind of movies that have popularized AI, like Her obviously was one of them, about everyone having a personal assistant. And even I think around the time Mark Andreessen wrote Software is Eating the World, I heard a talk from Vinod Khosla at FutureMed, where he talked about how AI, he would advise any of his friends' kids not to go into radiology or dermatology, because all the diagnostic parts of those fields, including, cardiology and other fields, would disappear. However, there's this concept, Amara's law, which I know you're familiar with, which is people tend to overestimate the impact of technology within a year, but underestimate its impact on the scale of 10 years. And I feel like we've kind of gone through a trough of disillusionment in AI and what it can do. But I'm curious, how would you think about those healthcare applications? Radiology is where you started with GE. You've done work on lung cancer detection, your lab has. Where are we with that right now, those applications for healthcare? Like, where are the strongest applications that are currently live for healthcare AI?
Yeah, look, more generally, I mean, I think there's some very interesting, like, before I give you sort of specific things where I'm actually not going to be the expert, and like where in healthcare we see lots of this, but let me sort of give a general view, which is, I heard one very famous computer scientist talk about this. He said, people ask him, are machines going to replace humans? Right. And he said, no, machines aren't going to replace humans, but humans with machines are going to replace humans without machines, which I thought was quite good. And then I added an asterisk, which is like the economics interpretation. And then if you have humans with machines, then maybe we'll need fewer of them, because you could have superpowers that allow you to sort of do way more. And so kind of like, my view of AI today in many settings is that there are some settings where there's been a complete substitution, right? So if you sort of think about ad auctions, we don't need human ad auctioneers telling us, like, that's all happening at scale at Google, right? Like, you do a search for Google throws you an ad, there's an ad auction in the background going on, fully automated. You don't need to touch it, right? Machines have taken over ad auctions. Machines have taken over music recommendations. I mean, I used to listen to a lot of DJs and radio growing up in Toronto, right? But then now it's like Spotify, and the algorithm just keeps telling me what to do, right? Similarly, machines also movie recommendations. Basically, Netflix gives me the movie recommendations I need. So certain parts of our lives have already had replacement, but much of where the action is going to be augmentation, where machines, will help humans, make some decisions, and in some cases take them over. And I think this precipice of how they will help humans and where in the process they will take over is TBD. We're still playing around with those kinds of things. And so specifically in medicine, I mean, I think what we want to start thinking about is, like, where is there grunt work being done by doctors? Where is there settings where performance of doctors collapses for a bunch of reasons, either fatigue, time of day. Some of my colleagues have done research on judges and sort of said that, the judge hasn't had a meal before, then you're more likely you're going to go to jail or not get your bail decision in your favor. So, like, what are those cases where doctors' performance fails? We assume constant performance and that all doctors are incredible. I take a statistical approach. There's a distribution of skill amongst doctors. Of course, everybody lives in Lake Wobegon and is sort of at the high end of the distribution. distribution, but realistically, there's a distribution of skill among doctors, and that skill is stochastic depending on time of day and other things. Like we know what happens in the June effect or July effect amongst doctors when the handovers happen. Right. And so we know all these things. And so the question is, how can machines help us there? And I think that's where I think we want to start taking this complementarity approach. We have been pretty much in the substitution story. I think we want to start thinking about complementarity, and then that could hopefully help us go after that. My view, though, overall, Shiv, before I'll shut up, is to think about 3 specific places where AI works really well, and then think about how that translates into medicine, right? One is predictions, right? You take a training data set and you learn from a bunch of folks making predictions, and then you say, can I make better predictions, and can the machine get better making predictions? And so imagine all the activities in medicine that are predictive activities that doctors do. And here machines can be helpful. The second, of course, is pattern recognition. This is, the thing around what pathologists do, what ophthalmologists do, what radiologists do all the time. They get a bunch of data and they have to sort of, images and make sense of it and do some pattern recognition. Well, machines can get really good at that. And the third thing is automation. How do you take manual processes and then how do you automate them? And if you can start to think about those 3 things as activities that also are happening in medicine: prediction, pattern recognition, process automation, what I call sort of the 3 Ps of AI, then we can imagine where these kind of things will start to augment medicine.
I love that framework, and we'll encourage our listeners, again, many of whom are actively going through school, engaging with patients in different settings for the first time, to think about those 3 that Karim just shared, because there may be some very compelling business ideas and ways to make clinical medicine more efficient that come right out of that. Obviously, there's people who've thought about a lot of these things already, but ultimately ideas are cheap, and it's really about execution and how good that is. One thing I'd like to
100%.
like to respond to as well, with the famous judge type studies of, I think it was Israeli judges, people who were sentenced earlier in the morning tend to have more lenient sentences, and then by the time lunch was rolling around and the judges were a little more hypoglycemic, a little hangrier, maybe they got less lenient sentences. A lot of people focus on how AI can, depending on your training data sets, can be very biased, right? Depending on where you, and the same is true of clinical medicine, clinical trials. There's a lot of arguments that it's biased. It's very, white male centric. But this is interesting because by standardizing, by having a machine that doesn't get tired, standardize kind of the diagnostic or the pattern recognition, you could potentially have an argument against the biases that we're finding when humans are fallibly diagnosing or doing other clinical procedures.
Yeah, absolutely. Look, I think that the question of bias is massive and huge, and I think we've moved away. My sense is that today in 2022, compared to 2012, when these systems were just coming on board, there was a naivete among computer scientists that, I got a data set, must be good, let me go train it, and then, oh my God, like we have all these problems. And the bias was both coming from how represented the data were, and then also who were the labelers who were labeling the data, whether they be physicians or other people, and then how you train the algorithms on top, right? There were 3 sources of bias. I think this view about bias is now, at least most cutting edge organizations are thinking a lot about that kind of bias. And we hope that over time we can, start to reduce that bias. At the same time, there's some bias and humans also have this bias too. Of course, we're finding this. And the hope is that over time we can in fact reduce the data science pipeline biases that are happening in algorithm development, and hopefully that helps humans who may have additional biases based on your glucose level. Like nobody thought that glucose level was actually going to be the factor that drives judges' decision levels, but in fact that's what it looks like. And so maybe we should also be wearing CGMs. All the doctors should be wearing CGM. Then we should be looking at how good you are, along the way. And then maybe the algorithm will come in and say, Shiv, you're like, you're declining. You better get some sugar in you and get some food in you to help you make better decisions along the way.
Totally. No, very, very interesting. And that's also one of the challenges. I know we've had guests like Eric Topol and Daniel Kraft on the podcast talk about, which is centralizing these data sources so that you can have more data. I mean, obviously garbage in, garbage out when it comes to data sources, but centralizing these data sources so that we have better algorithms that are more representative of the entire population. And we're recording this episode a couple of days after Amazon announced its acquisition of One Medical. Apple released a 60-page report about health, like how big they're going to be in healthcare, what their healthcare strategy is. So it's really exciting to see some of these big tech companies that have this tremendous data set get into the space. For example, there's a lot of excitement around with Amazon, say you're, they already have patents around Alexa. And when you're, say you're coughing a bit more when you're talking to Alexa than normal, automatically start recommending a prescription from PillPack or seeing a primary care doc now with One Medical. So it's kind of exciting the convenience that some of this AI or recommendation systems will provide. We've already seen it, as you've seen as you've shared in music and other fields. But in healthcare, it seems like we're just on the cusp of some really novel things.
I think so. There was some, I don't know how true it is. Other folks will know, like, for example, can you check for depression when you're talking on the phone, right? So that somehow, your phone companies should have better access to you than anybody else. And then maybe either from your texting patterns or from your talking patterns. And nobody's talking on the phones anymore these days anyway. But, are there ways to then, come up with measures of depression that could be early warnings for you? So again, I do think that there is the digital exhaust and the digital footprints of all of us has massively increased, and can we use those data to then drive some inference? I think it becomes quite interesting and exciting, and kind of scary, right? Because then all of a sudden we need to now be in this world of data privacy. Do I really want Amazon and Google and Facebook to have all my data? Well, I guess they kind of do already. And so we have to learn to figure out a new contract with these types of large companies as well around our data.
Yeah, totally. And on that specific point about, voice patterns and being able to predict depression or anxiety or other mental health conditions, two of our guests, Mainal at Ellipsis Health and Puneet at Suki Health, are both tackling that problem. So I recommend our readers or listeners go look at those. One of the case studies you've written is on Moderna and biotech, and how they are sort of very much winning the AI in biotech, not war, but the race. Can you give a description to our audience of that case and why Moderna is so far ahead, and maybe how that helped with their work on the COVID vaccine?
Sure, absolutely. So first, as a disclosure, I've been a sort of a key opinion leader for Moderna beforehand. I wrote a case on them, and I'm also now spending a substantial amount of time thinking about AI and biology at Flagship Pioneering, the company behind Moderna as well. So I just want to sort of provide disclosures around that. Look, I think the Moderna story is very interesting, and in many ways, for me, epitomizes how to think about AI in healthcare, generally, both in discovery and drugs, but also in delivery. And I would sort of give you like three big ahas, and then we can get into some details. The one big aha, and this was like in conversations with Stefan Bancel, the CEO of Moderna, and then having spent time in Moderna and thinking a lot about what Moderna was doing, which was different from the traditional biotech model, the traditional pharma model. One was, what Bancel talks about a lot is that discovery is all about data, right? And about data and experiment. Like, how do you think about your data? How do you think about running the experiment? How you extract the data from an experiment? How you analyze it? And the faster you can do those cycles of data, experiment, the better off you're going to be. In most discovery settings, we're still in the world of sort of lab notebooks, Excel spreadsheets, email, and people coordinating that way. And you can start to imagine that errors up front in hypothesis development and sequence development, let's say for biotech, you're doing some fancy Excel spreadsheet work and then you have an error. That can lead to massive problems downstream. And the more manual your processes are, the more likely you're going to have errors up front, and then also in your experiment and then data collection. And the timeline between the error being made because of manual processes and you getting and realizing that can be in the order of months, if not years, depending on what's going on. And so Benzel's view was, let's just automate the process by which discovery happens, automate and digitize, right? First, digitize the process so that the bozo errors that we all make when we are working don't get made, and they're corrected for. And so he worked quite a bit to make sure that the company's infrastructure for discovery was going to be digitally native. Now, of course, he's working with an information molecule in terms of mRNA, and so that was certainly amenable to that mindset, but he sort of took that view and made that core part of it. And then he added, along with his teams, a set of folks to sort of say, we digitize discovery, we automate the processes by which discovery gets done, so that again we reduce human error that could be introduced along the way. And so that's the second thing: digitize, automate, bring in AI along the way. And automation, you're constantly extracting data from the experiments you're running, from your lab systems, and so on and so forth. And then finally, I thought my biggest insight with hanging out with them was, and I think this has I think probably the most profound implications for all of us, not just in discovery but in healthcare in general, is an emphasis on process, right? Change the process. You now have this new technology. Make sure you change the process so that you can take advantage of new technologies instead of doing it the old way. So, my biggest complaint about all these EHR implementations in hospitals is we've taken these old crappy processes that got invented in the 50s, 60s, and 70s as to how to run large-scale hospitals, right? And we put EHR on top of them. So we basically digitized crappy processes instead of the work that was needed to be done, which is like, if I'm going to bring in modern computation, modern data analytics, let's rethink the way in which we actually run our hospitals, the ways in which we run our various clinics, and the ways in which we do those things. And Benzel sort of applied that relentlessly to his small biotech at that time. And the view has always been, let's make sure that we are actually pushing hard on process change and process improvement. So the example I use is, comparing, New York to Boston. There's a sports rivalry, of course, and at the moment we're sucking in baseball. We did better in basketball, but if you sort of go back to when the modern cities were being developed and asphalt got invented, Manhattan, New York said, we have these old cow paths and we're going to, in fact, stop and create a new grid, right? Philadelphia did that, Paris did that, and so on and so forth. Boston said, this poor asphalt or our old cow paths is fine. And, pre-Uber, pre-GPS, really, even now, with Uber and GPS, it's very easy to get lost in the city of Boston downtown, because it's just like a bunch of crazy cow paths that got asphalt put over. But New York or Philadelphia is at least sane. You say like East 15th and blah, and you know exactly where that is in your mind, and you can get there. So the grid system was invented. Essentially, I think what's happened with digital and with AI in most healthcare settings is that we're basically pouring digital and artificial intelligence asphalt over old cow paths, and we haven't rethought processes. And I think process change for me, is the biggest work that has to happen in healthcare across the board, from discovery to the clinic and beyond, to push this out. And that's why I think Amazon and Apple and Google will be interesting players, because there are two options. They could decide to, in fact, take the existing processes and be happy with it, or they might start to actually change processes. And I think that's where we'll see this stuff happen in front of us.
That's an incredible analogy. And having lived in Boston for 6 years, and then lived in Philly, but also been in New York a lot, totally relatable. I definitely think most people's healthcare experiences is more like Boston we want to make it more like New York. So.
And it's crazy, because you read all these encounters of like, I got this particular disease, or my aunt or my uncle or my parent got this, and I'm a PhD with blah, 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 and I spend months trying to navigate the healthcare system because it's so bloody Byzantine and it's full of these cow paths that we have. It's just nutty. So back to the Moderna story, those three things were really part of the story behind which enabled a company at the time of the pandemic with no drugs in the market, 800 people working at them, to be able to, within months, scale, run massive clinical trials, right? Go into production, right? Make billions of doses and show up. And I think the comparison between BioNTech and Pfizer and Moderna is very interesting because, here you have a startup really working with a collaboration between one of the leaders in the pharmaceutical space, right? And being able to hold their own, right? And the reason is because of their investments in technology and their process focus that enabled them to pull this off.
Yeah, and now that they're at that point, it's like, what does the next 5 years or 10 years look like for companies that are AI first, as you say, and make AI?
Yeah, exactly. And more generally, I think, and this is some of the work at Flagship, right, is that, the era of programmable medicine is finally getting in front of us, right? So if you sort of start to see mRNA and then all the other RNA type stuff that is being thought through, we may be entering this new era of sort of where the finally the revolution in biotech is actually merging with the revolution in technology, right? And we're going to see some very interesting outcomes come together. And if you sort of see now the investments that what Moderna is making, but every other company is making around mRNA, right? You get to see like, oh, we could be at the cusp. Again, we don't know if all this is going to work or not, but certainly there's lots of promise that this may be an interesting shift for us to sort of start thinking about programmable medicines.
Yeah, very, very exciting. And especially now, because we talked about data, not just privacy, but being able to get more data on people. Back when I think, some of these companies were starting, the cost to sequence the human genome was prohibitive. And now it's much under $1,000, I think, at this point. You can do it with next gen sequencing. So it'll be very exciting to see that. I'm aware of your time. So I had just 2 other questions, or really 2.5 other questions for you. The first is, as you know, Osmosis is a education company. We love teaching. We love simplifying things. If you could snap your fingers and teach the next generation of healthcare professionals anything, what would it be and why? And it could be, again, some of the things we were discussing, the role of AI or technology, but just more broadly, what are you thinking?
Look, I think healthcare professionals have you have to practice your craft, learn your craft, practice your craft, and also be researchers. So because one or the other, patients are relying on you to help them interpret the research and or participate in the research process. So that means, guess what? Much and more research is being driven by data science, statistics. And so first is, I would say, like, improving your grounding in, like, I don't want you to become data scientists, but you got to actually understand this stuff, right? And so what I say to MBAs is, when you come to HBS, you take a course in accounting. If we made accounting an optional course, nobody would take it. It's similar to right now in medicine where data science are optional courses, nobody will take them. But you need to know accounting to be able to be a good business person. To be a leader in a business, you actually need to understand how books come together. So my view is that the data science is going to become a required part of the medical career. And you just need to get good at that. And not to become a data scientist, but for you as a consumer of knowledge that is heavily data science driven. Hopefully some of you will become producers of knowledge. In both those cases, the data science training will matter. And the second thing I would sort of say is, guess what? All of you are managers. Whether you're running your own practice, whether you're in a hospital, wherever you are, you're all managers. And so again, appreciating the managerial roles you have above and beyond your craft, your clinical, your patient care thing is actually going to be important as well. Because in the managerial viewpoint, you would go and change the damn process, right? You would say, I'm not happy with this way my department is set up. Let's go fix it instead of sort of taking it for granted. And so I think the managerial leader role is as important as the data science role. And I would add both of those to the med school curriculum.
That's great. That's really, really helpful advice. And actually that transitions to the second to last question, which is, more broadly than what to learn to become become data fluent and become have some managerial skills or actively take roles in management so you can change the process. What other advice would you give to anyone starting their career right now, not just healthcare professionals, but given all the turbulence of the last few years and where AI may be in 5 years versus 15 years from now?
Yeah. Look, what I sort of say to people, and I think I'm not sure what the average age is if you're a podcast listener. So I could be like
mid 20s, most likely. Yeah.
Mid 20s. Okay, all right. So like when they were toddlers, or slightly 5 or 6 year olds. No, but what I say to people is just think back 20 years. Some of you were very young, so you may not even remember 20 years ago. But in 2002, we never imagined a world where there'd be companies that would be serving billions of customers effortlessly. There'd be companies with trillions of dollars of market cap, right? Or we'd have this magical world of AI that we're living in, or that we would have a pandemic, that the whole world would get shut down. And even if the world was shut down, we actually got our work done. Schools ran as best as they could. We taught in the MBA program during the pandemic. We figured it out, and that seems those things seem improbable, but became true just in 20 years. The rate of change in technology, the rate of change in AI is approaching exponential levels. And so now, what are the next 20 years going to look like when you're going to be at the prime of your career? Right? Lots of changes to be expected. And, one thing for sure is that we're going to be living around these exponential technologies. I'd really encourage people to read Azeem Azhar's book after reading my book, Azeem Azhar's book on the exponential age. And it really sort of highlights a few technologies that are growing exponential and what it means for us. Because most of us, including the healthcare system, lives in a linear world, right? Where we grow linearly, our capacity grows linearly. And, COVID showed us what happens when we live in an exponential process, right? Which is our healthcare capacity is going to collide directly with, which grows linearly with the exponential disease process, and chaos happens. But those things are in fact happening around the economy. And just getting familiar with these trends and then seeing what's your role in that is going to be important. But I think we're in for an amazing, incredible ride, both for the good and I'm afraid for the ill. And, healthcare professionals will need to be able to not do the push away the technology or push away the language or push away not the language, but push away this is technology. I don't care about that. I just care about patient care. Guess what? Patient care is all going to be about technology. And so you have to sort of embrace it and make it part of your identity as you go forward.
That's great advice. And certainly that trend, there's a whole conference called Exponential Medicine that's around some of those trends. That's been around for 10. That's actually where I heard Vinod Khosla speak about this stuff like a decade ago. Nice. And last question, anything else you want to share with our audience before we let you get on with your day? No,
look, I think what you're doing is fantastic. I wish everybody good luck to sort of, as they're embarking on their careers, how to navigate these complex times. But we really need leaders in all fields to go solve these tough problems. And we have, I think there's a bunch of slow pandemics we're in the middle of. Climate change, the climate change induced healthcare crisis is going to be massive. Nutrition, you name it. Lots of interesting slow pandemics are already sort of in front of us, and so we've got to find a way to solve for them. And healthcare is going to be critical. So I wish everybody best of luck as they take on these challenges ahead. We need this generation to also become the leaders that the world needs.
Absolutely. Well, Karim, thank you so much. This has been an absolute pleasure. I really loved your talk last month at HBS, and I encourage our audience to check out your book, watch some of your videos online, and just get familiar with AI and exponential trends, as you said.
Thank you, Shiv.
Thank you again. And with that, I'm Shiv Gaglani. Thanks to our audience for tuning into this week's show. And remember to do your part to flatten the curve and raise the line. We're all in this together. Take care.
For more information on how you can help raise the line and flatten the curve, go to osmosis.org/COVID-19. If you like this podcast, please share it on your social channels. You can also subscribe to the series and check out all of our podcasts at osmosis.org/raisethelines podcast.